Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry Chapter 8.1, Part 1. So Chapter 8, and please write this down in black, is Chapter 8, Compounds and Molecules. And some things you should be able to answer by the end of the chapter are, why are diamonds so hard? If sugar and salt look so similar, why do they have such different melting points? And why do they have different other properties? Can water bugs? How do water bugs walk on water? And then here are some chemicals, some compounds that are found in flowers, just for a fun thing to think about and look at. So let's jump into 8.1, which is about ionic compounds. So properties of ionic compounds. And if you know these, you don't have to write them down, but if you don't know these, you should write them down. So ionic compounds will be hard and brittle. They will be solid at room temperature. They have very high melting points. They conduct electricity when dissolved in water or when heated to a liquid state. And that they are neutral. So if you don't know those, feel free to write those down. And if you have them like, oh my gosh, I already know those, then you don't have to. I do want you to write this down. Properties that are related to chemical structure. So all properties are related to their chemical structure, so let's see how that works. Ionic compounds form crystals of negative and positive ions. A positive ion is attracted to all neighboring negative ions. Okay, so what? So this means that ionic compounds are hard and have high melting points. Why? Because each ion is bonded to a bunch of other ions, so that bond is strong, and it takes a lot of energy to break those bonds. In other words, it takes a very high temperature to melt a solid into a liquid. So the fact that ionic compounds are solid at room temperature is because one ion is attracted to, like, let's say 6 other ions. 1, 2, 3, 4, 5, 6. Also, ionic compounds are brittle. So if you were to take like some salt, like a chunk of salt, and break it, it would just shatter. Why? Because if the pressure is applied to one side of a crystal, the ions move so that the negative ions are lined up with negative ions, and the positive ions line up so they're aligned with positive ions, which means the ions repel each other and the compound shatters. So let's take a look at this. It'll make more sense. So here is an ionic compound where we have the positives and the negatives are sitting next to each other. And then if you apply a force, like maybe you have a hammer and you go and you hit this towards the right, you see that it shifted over, and now the negatives and negatives and the positives and positives are next to each other, and they do not like that. They are repelling, and what happens is that crystal just shatters instead of like if you hit gold, it'll deform and stay there, whereas salt will just, if you hit it, it will shatter. So salt is not ductile or malleable. It is brittle. Another property is that ionic compounds conduct electricity when dissolved in water. And let's break that down a little bit. Well, what is electricity? It is the electric current, and electric current is the flow of electrons or flow of ions kind of in one direction. So in water, the ionic compounds dissociate into ions. So sodium chloride breaks apart in water, and you have positive sodium ions and negative chlorine ions just floating around. And when positive and negative electrodes of an electric circuit are put into water, the ions move towards the electrodes and they make a circuit. They make an electric current. Taking a look at a picture, we have a sodium chloride crystal, and then you put it in water, and you can see that it breaks up into its chlorine, negative chlorine ions, and its positive sodium ions. And if you were to put electricity in there, then the positives would flow one way, and the negative ions would flow another way, and you would have an electrical current. You'd have a flow of ions. Another thing you will need to know are polyatomic ions. Let's look at that word a little bit. It is an ion, so it has a charge, and it's many atoms, polyatomic. So it's a small molecule with a charge. Please write that down. Let's go into that a little more in depth. So it's atoms that are covalently bonded to each other, but overall the molecule has a charge, and the molecule will form an ionic bond with another ion. So write that down, and then let's talk about it. So you have a couple of atoms that are covalently bonded together, and then as all together they have a charge, and then that unit, the polyatomic ion, works as a unit, as an ion in an ionic bond. So let's look at an example. One example is ammonium. So ammonia is NH3, and that would be a neutral molecule, where ammonium is NH4. So let's break it down a little bit. If we were to do the Lewis structure, nitrogen has 5. So we did 1, 2, 3, 4, 5. And then we put in one hydrogen there, one hydrogen there, one hydrogen there, but there's 4 hydrogens. So then I put another hydrogen there, but it brought its electron. So I had 5 from nitrogen and 4 from all of the hydrogens. So 5 plus 4 would be 9 electrons, but we can see we only have 8 here, which means it lost 1 electron, which means if you lose an electron, you have a +1 charge. So not one atom, but the whole molecule together carries a +1 charge, and it acts like that. So we know chlorine has a -1 charge, and ammonium has a +1 charge, so they form an ionic bond. Ammonium +1, chloride -1, it makes an ionic compound. You may be wondering if there are any other polyatomic ions besides ammonium, and indeed there are. So I do need you to write these down, both the name and the chemical formula. Hydroxide is OH, and it has a -1 charge. Nitrate is NO3, and it has a -1 charge. Acetate is C2H3O2, and it has a -1 charge. And hydrogen carbonate, which is also known as bicarbonate, is HCO3 with a -1 charge. And then if we take off the hydrogen, we have just carbonate, CO3, with a -2 charge. Sulfate also has a -2 charge. It is SO4. And phosphate is PO4 with a -3 charge. We are going to be having a quiz on those. So I'm going to need you to memorize the name, the chemical formula, and the charge. It seems like a lot of work now, and it will make your life easier for the rest of the year. So you want to start practicing those polyatomic ions. Another important thing to be able to do in 8.1 are to write formulas for ionic compounds. And we're going to go through the balancing method. So the first thing we're going to do, and this is a review from 7.2, so you may write the stuff in blue, or you don't have to, is you write the atomic symbol and charge of each ion. So let's talk about magnesium chloride. So we know that magnesium is Mg, and it forms a +2 ion, and chlorine is Cl, and it forms a -1 ion. And then the next step, if you remember from chapter 7, is you figure out how many of each ion is needed to make a neutral compound. Well, if I start out with 1 magnesium, I have +2, and then if I have 1 chlorine, I have -1. Well, +2 - 1 is still +1, so I'm not neutral yet. I need +2 minus 2, which means I need 2 chlorines to be able to get to 0. So I have 1 magnesium and then 2 chlorines. So let's check. Does +2 minus 1 equal 0? It does. Then the next step is you use the number of each ion as its subscript in the chemical formula, but we don't write 1. We just assume that. And we don't write any of the charges, so this plus and this minus goes away. So our answer is MgCl2. Okay, now it's your turn. So I want you to come up with the chemical formula for aluminum oxide and for sodium sulfide. Okay, now that we're getting good at that, we're going to up our game a little bit and we're going to write formulas that have polyatomic ions. So what do? If more than one polyatomic ion is needed in the formula, you put parentheses around the whole polyatomic ion and then you put subscripts after that. So writing a formula with a polyatomic ion is just like writing a regular formula unless you have more than one of those polyatomic ions, and then we need to tell people that. So this is how we tell people that. So let's go with calcium nitrate. So first thing we're going to do is we're going to write down their chemical formulas, so their atomic symbols and their charges. So calcium is Ca plus 2, and nitrate, remember, is one of our polyatomic ions. It is NO3 minus 1. Okay, so we have calcium and nitrate, and so we can see that these are not going to equal each other out. So we're going to need 2 nitrates, because a -1 and a -1 would balance out our +2. So how do we write that? Well, I'll show you 2 examples. Okay, so here we have 2 examples. We have calcium and then nitrate, and so we have our subscripts just waiting in the wings. And if I bring this over here and I give myself 2 nitrates, wait a minute, that's not 2 nitrates. That's 1 nitrogen and 32 oxygens, which is not what we wanted. So we do not want to do it that way. What we do want is 2 nitrates, and the way we tell them that is with parentheses, because there's 2 nitrate. Okay, now it's your turn to do the chemical formula for aluminum hydroxide. And if you want more practice, you should do magnesium sulfate or calcium phosphate and ammonium sulfide. Another important thing you should be able to do in 8.1 is writing names for ionic compounds. So we did from names to formulas. Now you need to be able to do from formulas to names. So how do we do that? Well, the first thing you're going to do is you're going to name the metal. So write the name of the metal. And then you're going to write the root of the nonmetal and then add the suffix IDE. So let's do this one. So this is the metal, Na. So I'd write sodium. And then fluorine is the nonmetal. So the root is fluor. And then I I add the suffix IDE, fluoride. So the name of this is sodium fluoride. So that is sodium fluoride, NaF. What do I do if there's a polyatomic ion? Well, basically nothing. So you don't change the name of the polyatomic ion. So this wouldn't be, so this is magnesium carbonate. It would not be magnesium carbide because that is something totally different. So this is magnesium carbonate. Okay, magnesium carbonate. If there's a polyatomic ion, leave its name as it is. Well, I would like you to do some practice of Mg parentheses OH2 and CaBr2. We will do one more quick video where we finish up 8.1 and go about naming ionic compounds with transition metals. I'll see you then. Bye.